An oxidation reduction titration or a redox titration is a titration where we're mixing two substances and a redox reaction is going to happen. So the objective for this experiment is to determine the exact concentration of a potassium permanganate solution, and we're going to be using for that a solution of a known concentration of oxalic acid. Besides doing that, we're also going to be using the solution of potassium permanganate to determine the concentration of an unknown solution of oxalic acid. So I have here a very simple representation of what you're going to be having in this experiment. You have two substances that are being mixed, and then if you have a redox reaction, what is happening is that electrons are being transferred. So the electrons are going to be transferred from one substance to another substance. So whatever substance you have, and I'm using the first square here in my diagram, whatever substance you have that it's losing electrons, that's the substance that is going to be oxidized. The substance that is losing electrons is losing electrons that are going to be used to reduce another substance. That's why whatever substance you have as being oxidized, it's your reducing agent, because the electrons that that substance is losing, those electrons are going to be reducing another substance. So my electron in red is being transferred to the second substance, or my second square here. So your second substance is gaining the electrons, which means that it's being reduced. The substance that is being reduced is also known as the oxidizing agent. It's the oxidizing agent because it's responsible for oxidizing something else. The processes oxidation and reduction, they always happen together, both things. If something is losing electrons, then another substance is going to be gaining those electrons. So you can see on the right side of the arrow that the substance that is losing the electron, now you have just the proton, and then the second substance on the right side of the arrow is the one that is gaining the electron. Okay, so you're going from a substance with one proton, one electron, to a substance with just one proton because it's losing the electron. And then the second square on your reactant side, you have two protons, one electrons initially, but that substance is gaining an electron to give you the second product on the right side of the arrow, where you have your two protons, that's not changing, and now you have two electrons, one that you had initially plus the one that that substance is gaining. The reaction that we're using is between the potassium permanganate and the oxalic acid, which are the two first reactants that you have in this equation here. So the ratio between your permanganate and your oxalic acid is 2 to 5. For every 2 moles of potassium permanganate that are reacting, you need 5 moles of oxalic acid. 2 and 5 are your coefficients, which is what we're going to be using in our calculations. We're going to have a known number of moles of oxalic acid that we need to convert to moles of permanganate. And for that, we're using that conversion factor. You have here the net ionic equation, which is showing you, or like the one that we're using to identify which substances are being oxidized, which substance is reduced, and how the oxidation number is changing. Whatever substance is being oxidized, the oxidation number will be increasing. You can see that in my diagram here again. My first square is the substance that is being oxidized. It's losing an electron. If you have one proton and one electron, your oxidation number is going to be 0 in that case because your charges are canceling out. Now, when that substance loses electrons, and you look at the other side in your equation here, The one that is losing the electrons, it has just now a proton. So you have a charge that is a positive number. So you're going from 0 to positive 1. That oxidation number is increasing, which is always true for substances that are being oxidized. Substances that are being reduced, the oxidation number will be reduced. Okay? Oxidation number for something that is being reduced will decrease because something that is being reduced is gaining negative charge, becoming more negative. Now, getting back to the reaction that we have down here, my net ionic equation. You have your the permanganate ion. We can calculate the oxidation number of your manganese in that permanganate ion. Oxygen in group 6 has a charge of -2. You have 4 oxygens. So 4 oxygens, each one with a charge of -2, that will give you 8 negative charges. Now, since that's a polyatomic ion, you have an overall charge that is equal to -1. If you have 8 negative charges, the number of positive charges that you need to add to 8 negatives to have an overall charge equal to -1, it's +7. +7 plus -8, that's equal to -1, which is the overall charge that you have for your permanganate ion right there. So the oxidation number for manganese is +7. The carbon in the oxalic acid, you cannot assign a charge or an oxidation number to carbon looking at the periodic table, but you can assign an oxidation number or a charge for hydrogen using the periodic table and for oxygen. So you can assign those numbers and then you can solve for the charge of carbon or the oxidation number for carbon. Hydrogen is +1 and you have 2 of them. Oxygen here is the negative. You have 4 oxygens and each one is -2. So you have a total of 8 negative charges coming from the oxygen, which means that between your hydrogens and your carbons, those oxidation numbers, they need to give you 8 positive charges. The oxalic acid molecule, it's neutral. You don't have an overall charge. It's different from what you have for your permanganate, because for that one, you do have an overall charge of -1. So you have a neutral molecule, which means that all of your negative charges has to be canceled with the positive charges that you have. So we do know that we have 8 negative charges because you have 4 oxygens and each one is -2. That gives you your 8 negatives. Now you have 2 hydrogens, which means that from your 2 hydrogens, you're getting 2 positive charges. Those 2 positive charges will cancel 2 negative charges, which means that out of your initial 8 negative charges, you're canceling out 2, and now you have 6 negative charges. So your 6 negative charges, they have to be canceled with the charges of your carbon or your oxidation number for carbon. You have 2 carbons, which means that each one is going to have a charge of +3. So let's think about this. If you have 1 carbon with a charge of +3, that's 3 positive charges, and another carbon with 3 more, that gives you a total of 6 positive charges right there, plus 2 positive charges from the hydrogen, that's a total of 8 positive charges. And you can cancel out your 8 negatives for the oxygen. So the oxidation number for carbon in oxalic acid is +3. Now on the product side, you have carbon dioxide and your manganese ion. This is in the net ionic equation. The manganese ion, you can see the charge is already +2. So the oxidation number for your manganese is going from +7 on the reactant side to +2 on the product side, see what's happening to that oxidation number. That oxidation number is decreasing because your permanganate is the one that is gaining the electrons. Since it's gaining the electrons, your oxidation number is going down. Now for the carbon in carbon dioxide with two oxygen atoms, each one is -2. Group 6 in the periodic table, oxidation number is -2. So you have two oxygens, each one is -2. That gives you a total of 4 negative charges, which means that to cancel out your 4 negative charges, the carbon in carbon dioxide it's going to have a charge or an oxidation number equals to +4. 4 positive charges in carbon, and you have 4 negative charges for your oxygens, and they cancel out because carbon dioxide is a neutral molecule. You don't have an overall charge for carbon dioxide. So now looking at what's happening to the carbon on the reactant side, where you have carbon in oxalic acid, oxidation number is +3. Now that number is going to +4 in carbon dioxide. So the oxidation number for carbon is changing from +3 to +4, which means that carbon is being oxidized. That oxidation number is increasing.